Okay, section 3.2, the derivative as a function. So what we did last section was the derivative at a point, which then gave us very specific numbers. Like we found that we did one problem that said find the slope at a point, and the answer was -8/9. Then another one, find the slope at a point, the answer was 1/4. That we got very specific numeric answers because we were doing derivatives at points. But for many applications that we're going to be doing, for most applications we're going to be doing, we would prefer to have the derivative be a function, have the derivative be a formula that we could apply to lots of different numbers, not just specific numbers. And so we're going to do the derivative as a function. And so we start with the definition. The definition, the derivative of the function f of x with respect to x is the function f prime of x. And so this right here is read f prime of x is given by f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x over h, provided the limit exists. And so you're looking at it going, well, that's the exact same thing that we had before. Instead of x's, they were x naughts. It's exactly the same. It's really close to being the same, but it's not exactly the same because x naught, x sub 0, represented a number. Here, x is a variable, and so your answers are going to have x's in them. So here, that's supposed to be a star. It doesn't look anything like a star. I told you last section that you didn't have to memorize that definition, but you do have to memorize this one. You will be asked on a test and quiz to state the definition of the derivative. You must respond with f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x over h. There will be no partial credit awarded to answers that are not perfect. You need to memorize this one, not with the x naughts, with the x. And notice it's h goes to 0. The most common mistake, other than people not knowing it, is that people put x approaches 0. The variable for the limit is h. And this bothers some students that you got two letters there, x and h, but we will get used to it. So there was one notation for the derivative, f prime of x. All these things here also are notations for the derivative. F prime of x, just y prime, dy dx, d dx of f of x, capital D sub y x, df dx. Those are all notations for the derivative. So you see any of those, you know it's asking you to find the derivative. Now I've said this before and I'll say it again. Yes, there are shortcuts to finding the derivative, and we will start those shortcuts in the next section. But you do not get to use those shortcuts until we get to the shortcuts. You may check your answers with the shortcuts if you know the shortcuts, but you cannot get your answers if you were told to use the definition of the derivative. And I will have a quiz problem and a test problem where it'll say, using the definition of the derivative, find the derivative. And if you do anything else, it's no credit. We'll get to the shortcuts next section. How to find f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x over h. Very similar to what we were doing in the last section. Apply the rule for the function to f of x plus h and f of x. Be sure you use parentheses where necessary. 2, simplify the numerator as necessary. If f of x is a polynomial, try multiplying out and combining like terms. If f of x is a fraction, try moving the over h off to the side as times 1 over h. Then combine the remaining fractions into a common denominator. Using a common denominator into a single fraction, simplify. If f of x is a radical, try rationalizing and simplifying. We did all those, we practiced all three of those in the last section, and it's still the same. 3, if you've done your work correctly, all terms should contain an h, cancel the h. 4, evaluate the limit, substitute h equals 0. So very similar to the previous steps, almost exactly the same. So using the definition of the derivative, calculate the derivative, then find the derivative, then find the values of the derivative specified. So the first thing we want to do is we want to find y prime, or if f of x equals 4 over 2x minus 5, find f prime. I just like f's better than y's. You can use whatever letter you want, doesn't matter. So f prime of x is the limit as h goes to 0 of f of x plus h minus f of x all over h. And we are just going to start doing those problems again. Doing that process, same process as before. And so that's the limit as h goes to 0. Find f of x plus h. And so that's going to be 4 over 2 times the quantity, x plus h minus 5 minus f of x, which is just the formula, all over h. So there's f of x plus h, there's f of x. Remember, f of x plus h is just the formula replacing the x with x plus h and using appropriate parentheses. And now we want to simplify. Now, I said it before in the previous section, and again I'll say it here. If we were to substitute h equals 0, we'd get 0 over 0, and that's indeterminate. And so our hope here is to do algebra to cancel the h. Do algebra that will allows us, yes, to cancel the h. So the first thing we're going to do here is get rid of that awkward over h. And I'll do a little simple multiplying along the way. And so that awkward over h, I'm just going to bring it off to the side as times 1 over h. Because why I can do that is that over h really just means divided by h. Fractions are nothing but division. So every time I say over h, I'm being a bad mathematician. I should say divided by h. So divided by h. Well, division by h, dividing by h, is the same thing as multiplying by the reciprocal. The reciprocal of h would be 1 over h multiplying by the reciprocal. So you can always replace that over h or divided by h times 1 over h. And then I just did a little algebra down there. And so these guys right here, we're going to combine into a single fraction. Well, when I'm combining fractions, or in this case subtracting fractions, I need a common denominator. So we will do that. The common denominator is going to be the product of the two denominators you see there. So it's going to be 2x plus 2h minus 5 times 2x minus 5. So the first fraction needs the 2x minus 5. Give it to it, top and bottom. The second fraction needs the 2x plus 2h minus 5. So top and bottom, numerator, denominator. Simplify. I'm going to distribute here. And I'm going to leave that minus sign for later. And so I have 8x minus 20 over 2x plus 2h minus 5 times 2x minus 5 minus 8x plus 8h minus 20 all over 2x plus 2h minus 5, 2x minus 5. Still times 1 over h, showing every step I can think to show. Now we have a common denominator, so I can subtract these fractions, being sure to distribute that minus sign there. That's why I saved the minus sign for a special step, so I can remind you to distribute that minus sign. I keep writing the limit symbol down, and notice when I'm going to write it out. And so I'm going to have 8x minus 20 minus 8x minus 8h plus 20 all over 2x plus 2h minus 5, 2x minus 5 times 1 over h. And I've got all sorts of stuff that's going to cancel. 8x minus 8x, minus 20 plus 20. And so I'm down to negative 8h over 2x plus 2h minus 5 times 2x minus 5 times the 1 over h. And there's my algebraic goal. I can now cancel those h's. That's always your algebraic goal, which then gives us the limit as h goes to 0 of negative 8 over 2x plus 2h minus 5, 2x minus 5, and then substitute h equals 0. So once I've canceled those h's, it's now time to substitute. That's not any straighter. It's now time to substitute that h equals 0. And so we're going to get negative 8 times 2x plus 2 times 0 minus 5 times 2x minus 5, which is negative 8 times 2x minus 5 times 2x minus 5 for negative 8 over 2x minus 5 quantity squared. And so what we have just shown is for y equals 4 over 2x minus 5, y prime equals negative 8 over 2x minus 5 quantity squared. And that's where we will stop this video.